I cut and paste the code into an IDE, so we'll add some logging statements here using the Hardhat console.log tooling to get a better picture of what happens as these contracts execute. So we've added code to the constructor that logs some things. We've added code to the pwn function and the constructor and fallback in the delegation contract. I like to work with the Ethernaut challenges inside Hardhat tests. It just makes it easier to manipulate things. So let's take a look at what is happening in each of the delegate and delegation contracts. Delegate has a public owner. It has a constructor that takes an owner address to start with. I've added some logging, but their code just sets the owner field that's in storage to the underscore owner parameter to the constructor. Pwn is simple. All it does is it sets owner in storage of the delegate contract to message.sender. Delegation also has a public owner field in storage and also a delegate. When you deploy the contract, you give it the address of the delegate, which is going to be the address that this is at. I added some logging. All it does is the constructor just sets delegate and owner to be the parameter for delegate address and message.sender for the owner. So whoever creates this contract is originally set as the owner. A contract can have a fallback function, and you'll want to look at this documentation. I'll include a link for exactly when the fallback function is called and what parameters it gets. And here's the fallback function in delegation that'll get called when we send Ethereum to the contract. We've got some logging here. And then we actually have the meat of the function. This is from the Ethernaut challenge itself that says, do a delegate call with message.data. And hopefully that will end up doing what the challenge wants you to do. And then we just have some more logging after that. So this is the test we're going to use to exercise the Ethernaut code. And it's not really a test, it's just a convenient way to interact with contracts and print out information. This just gets you one of the default Hardhat accounts that is able to sign. This is the one we're going to use with our own private key that you'll generate. We'll mostly be using that to interact with the actual contract on Gurley eventually. And then this is fairly standard Hardhat. We're going to deploy delegate contract, and we're going to call the constructor with the address of the initial deployer account. Delegation contract is similar, but we're going to call it with delegate contract's address in the constructor. Then we log some information. We do a basic expect here to just say that the state of the world is what we think it is. This is the kind of thing I like to do to make sure my assumptions are actually happening in the real world. Make sure that you don't already accidentally own things that you're trying to test yourself on. Then the next thing we do is we want to compute the Ethereum function selector for the pwn method. So this is the delegate.sol. In delegate, we're eventually want to call this. The first argument to delegate call is going to be the function signature. And you compute that by taking the name of a function, the name of a public function, and all its parameters. In this case, there aren't any, so it's just going to be open paren, close paren. I'm going to set a breakpoint in Ethereum function selector, and then I'm going to run this. It's the first interesting thing. Everything else is just set up contracts on the local test chain. So we're starting up. Let's go back to delegate.sol for a minute so you can see these outputs. So you'll see the delegate constructor is called with the owner and the this parameter, and we haven't called any of those yet. The delegation constructors have also been called, so we're seeing these outputs, and these addresses will be interesting eventually. So back to the debugger. The first thing we need to do is we need to turn function signature into UTF-8 bytes. So step through that, and you'll see that function signature as UTF-8 bytes is now an array, 112, 119, 110, and those are just Pwn turned into the ASCII values for those characters. Then we compute the Keccak 256 checksum of those bytes, giving us a checksum, which you've seen before, right? There's nothing special about that checksum. We care specifically about the first 4 bytes of that checksum. That is what the signature is. So we're going to first get the 0x followed by 4 of those. So the first 4 bytes of the checksum are DD, 36, etc., etc. And then we arrayify that. Arrayify is just the built-in utility that takes those that string and turns each of these into a byte array-like. And the result is the bytes the way we're going to want them here. So we're going to send transaction. We're going to send it to the delegation contract. We actually don't care how much Ethereum we send. We could have put anything in there. It's irrelevant. For this particular test in general, it's not irrelevant. And we're going to call it with that function selector. And that output is interesting. So I'm going to continue here. Okay, so we have made that call, and now we've seen some more output here. You'll notice that we're calling the delegation fallback method, printing out the message sender, and the current delegate field. And this is interesting because normally when you make a function call to another contract, message sender would get replaced with the address of the delegation contract. So you can see here that we've made the call, we're in fallback, we're calling address delegate delegate call with message.data, that's that function signature. You'll see these message sender and delegate match with message sender and delegate. And then you'll notice that it's ended up calling delegate Pwn. So we have called, so we're dereferencing, not dereferencing, we are casting this delegate field to be an address, and then we're calling into it with the selector we've calculated for this function. And you'll see these console.logs outputting here, and you'll notice that message sender is the same in delegation fallback and delegate Pwn, which is not what you would normally expect if you're not using delegate call. So we're inside Pwn, and we're going to call owner equals message sender, and this owner is going to be the storage for this contract. So going back to here, when I continue, we're going to expect that because we've set that owner field inside Pwn, but on the storage of delegation, on the storage of delegation contract, we've now won, and our tests pass, except that in a debugger you time out. So rerunning the tests, not in debug mode, pass. So that's what delegate call does.